In this lesson, we will learn about paper and thin layer chromatography, both of which are used in forensic science applications. Chromatography is a separation technique, and this will be demonstrated using food coloring. Using a pencil, draw a line at the bottom of a strip of chromatography paper. Dab a small spot of red food coloring on the pencil line and repeat with green and blue food coloring. Place this in a beaker with water, ensuring that the water level does not touch the spots. As the water is absorbed, it separates the multiple components of the food coloring. We have now created a chromatogram. The chromatography paper is called the stationary phase as it stays put. Water is called the mobile phase as it moves up the chromatography paper. Here is the key idea. A component that is more soluble in water travels a greater distance up the chromatography paper, and a less soluble component travels a shorter distance. The retention factor, or RF value, is a measure of the distance that a separated component has traveled compared to the distance that the solvent, in our example, water, has traveled. These distances can be measured using a ruler. What does the retention factor value tell you about the solubility of a separated component in the mobile phase solvent? Please pause the video to think about this and resume when you are done. A larger retention factor value means that the component is more soluble in the solvent. A smaller retention factor value means that the component is less soluble in the solvent. Thin layer chromatography, or TLC, works in exactly the same manner. Instead of chromatography paper, a glass plate with a thin layer of silica gel or any other adsorbent material is used. This thin layer of adsorbent material is the stationary phase. A suitable solvent may be used as the mobile phase. If the separated components are colorless, the dried chromatogram may be sprayed with ninhydrin, which can turn some components purple. Or the chromatogram may be viewed under UV light. Ninhydrin is used to detect fingerprints from a crime scene. These chromatography methods can be used to identify and compare samples of drugs, inks, lipsticks, saliva, and explosives, just to name a few. In conclusion, paper and thin layer chromatography are used to separate components of a mixture based on their solubility. The relative solubility of the separated components can be determined by calculating their retention factor values. More soluble components have a larger retention factor value, and less soluble components have a smaller retention factor value.